The purpose of this lab was to find the limiting reactant in the double displacement reaction, where 1 mole of copper sulfate reacts with 2 moles of potassium hydroxide to yield 1 mole of copper hydroxide and 1 mole of potassium sulfate. Here is the formula that shows this equation. We utilized concepts like stoichiometry and the law of conservation of mass to determine the limiting reactant at different stages of the lab.
Stoichiometry is the study of quantitative relationships between reactants and products and is based on the law of conservation of mass. The law of conservation states that matter is neither stored or created, only transferred. The product that forms is precipitate. Precipitate is a solid that forms in a solution during chemical reaction. The liquid around the substance was a supernatant. Supernatant is a clear liquid that sits above a solid that has settled or been settled by centrifugation. The limiting reactant is the reactant that limits the amount of product to be produced due to insufficient amounts. Using the equation T for tank plus 3Fi for fish, it yields TFI of 3. If we have 5 tanks and 19 fish, and 3 fish go in each tank, there will be 4 fish left, making the tanks the limiting reactant.
For this lab, we used 2 barrettes, 1 stirring rod, 8 test tubes, a graduated cylinder, 2 beakers, 2 funnels, and a test tube rack. We first started by cleaning all the lab equipment with distilled water to prepare it for the lab. We then filled 1 barrette with KOH and the other with CuSO4. We labeled 8 test tubes and added 5 milliliters of CuSO4 to each. In tubes 1 through 8, an increasing amount of KOH was added to each tube. We added enough distilled water to each tube for it to equal 13 milliliters. Once each test tube was filled, we waited for 15 minutes for the precipitate to form and a reaction to occur.
Before the reaction, we observed that copper 2 sulfate had the consistency of water, a blue tint, and was partially transparent. We also noticed potassium hydroxide also had a consistency like water, was clear, and is also transparent. Our last observation before the reaction was when CuSO4 was mixed with water, it looked like a light blue cloud in the test tube. After the reaction happened, we saw a gradual increase in precipitate from test tubes 1 through 4, while also having a light blue color. In test tubes 5 through 8, the precipitate started to level off and the color became darker as it went on, with test tubes 7 and 8 looking almost black. This graph shows our quantitative data where the x-axis is the test tube number and the y-axis is the height of the precipitate. This diagram displays how the height of the precipitate was slightly increasing in test tubes 1 through 4 and leveled off in test tubes 5 through 8.
In test tubes 1 through 4, a constant amount of CuSO4 was added with an increasing amount of KOH in each test tube. As the KOH increased, the height of the precipitate increased as well. This shows that the limiting reactant in tubes 1 through 4 was KOH. In tubes 5 through 8, KOH was still the limiting reactant. We would expect that the height of the precipitate would continue to grow. This is not the case. Instead, the height of the precipitate leveled off. With this information, we can infer that the limiting reactant switched to CuSO4.
Our experiment was inaccurate in test tubes 5 and 6. We believe this is because we did not put enough KOH, which kept it as a limiting reactant, causing the height of the precipitate to be less than expected, and closer to the height in test tubes 1 through 4.